Assalamu alaikum everyone. Welcome to my lecture. Today we're gonna learn about quadrilateral angles and the unit circle. Let's start with the quadrilateral angles. If the terminal ray of an angle is in standard position and it coincides with any of the axes, this means any of the x or y axis, then it is called a quadrilateral angle. The measure of a quadrilateral angle is a multiple of 90 degrees. What does this mean? So first, here we have a Cartesian plane with positive y-axis, positive x-axis, negative x-axis and negative y-axis. So let's assume that this point, that is 0 degree. This is the first quadrant. Then this is the second quadrant and here we have 90 degrees. In the third quadrant we have 180 degrees and in the fourth quadrant we have 270 degrees. So if we convert this to radian measure, 0 degrees in radian measure is 0 radian, 90 degrees in radian measure is pi by 2 radians, 180 degree in radian measure is pi radians, and 270 degree in radian measure is 3 pi by 2. But when we go back to this 0 degree, now a full rotation has been completed and the degree will be 360 degree. So the radian measure will be 3 pi over 2 radians. Now what are quadrilateral angles? If the terminal ray represents these 4 points which I have stated, 0 degree, 90 degree, 180 and 270. So if the terminal ray of an angle in the standard position coincides with any of the x or y axis, then it is called a quadrilateral angle. So let's assume we are starting from the point of 0. So when a whole rotation is completed, that means that the starting point was 0 and 360 degrees has been covered. So we can write 0 degree 3 comma 360 degree. After that, if we take again another rotation, then it will be 360 multiplied by 2. And if we take another rotation, then it will be 360 multiplied by 3. So now if you start with the point of 90 degrees, if you start from this terminal ray, so instead of your starting point being 0 degree, now it's 90 degree. It's your starting point. So you can write that here. After that, a whole rotation when it is completed and your terminal ray comes back to here to the 90 degrees, now it is 90 plus 360. After that, if another rotation is completed, then we will have 90 plus 360 into 2, because 2 times the rotation has been completed and our starting point was 90 degrees. Now if you look at 180 degree, if we start from this terminal point, so that means that our starting point is 180 degree. After that, if we take a full rotation and the point comes back to 180 degrees again, that means that we can write 180 plus 360 degrees. And if the rotation is then again completed for the second time, we can write 180 added with 360 multiplied by 2, and so on for how many rotations it is completed. Now if you look at the third quadrant where you have 270 degrees, if we take our starting point from 270 degrees and a full rotation is completed, that means that the first starting point was 270 and then 270 degree was added with 360. Another rotation is, for example, completed, so that means 270 degree is added with 360 and that is being multiplied by 2. And if you come to the last quadrant, which is 0 degree, so that will be just the same. That's why we wrote it first. So these are the terminal rays which are along the positive x-axis, positive y-axis, negative x-axis and negative y-axis. Now, let's move on to the unit circle. What is a unit circle exactly? A circle whose radius is of 1 unit is called a unit circle. In standard position, the center of a unit circle is O, and O represents the origin. Let's assume that I have a circle drawn here, and inside of that circle, I have the Cartesian plane, which consists of positive and negative x and y axis. So here I have taken from the center point. This is the center point right now. Let's call that O. That stands for the origin. And then I have drawn the radius along this circle. The part which is highlighted represents the radius. And that radius is of 1 unit. So that means that inside a circle we have a Cartesian plane and the radius is drawn of 1 unit, so this represents a unit circle. Now, after I have drawn the radius, then I took a perpendicular line which is drawing below. So inside this unit circle in the first quadrant, the quadrant which I just am shading right now, we have a right angled triangle. And here the base, let's assume that is x, the perpendicular that is y, and the hypotenuse we call that 1. Why did we call the hypotenuse 1 instead of h? That is because we know that the hypotenuse is also equal to the radius. It is the radius. So the radius was of 1 unit. So that is why we wrote instead of h and instead of r only 1. Now here this 90-degree perpendicular, if you look alongside it, we have the value of theta. Theta represents the degree or the value in radian measure. Now, what is the equation of a unit circle centered at O or the origin? That is the Pythagoras theorem. So if you look at the base, take the square of the base, add that with the perpendicular of the base, and that will be equal to 1. So we can write x square plus y square is equal to 1. Now I didn't write 1 square because the square of 1 is also equal to 1. So this is the standard equation of the unit circle. Now let's assume that I have a triangle that is drawn. Now let's move on to trigonometric ratios. Trigonometric ratios are the ratios between any two sides of a right angle triangle. There are 6 possible trigonometric ratios corresponding to an angle. In the triangle A, B and C, angle C is equal to 90 degrees, angle A is equal to theta, and side of AB is equal to C, lowercase c, and side CA is equal to lowercase b with respect to a base, and C is the length of hypotenuse. Now we are going to define the various trigonometric ratios. First, let's discuss sine theta. So sine theta is equal to A over C, which means perpendicular over the hypotenuse. So we can write sine theta is equal to A over C. After that, we have cos theta. So cos theta is equal to B over C, which is base over hypotenuse. Then we have tan theta, and tan theta is equal to the perpendicular over base. That means A over B. Now these are the 3 main trigonometric ratios or functions, however you want to call them. What is their reciprocal? Reciprocal means what is their opposite. For example, we have sine theta. The opposite of sine theta is cosec. So we can write cosec theta and the value of cosec theta is the swapping of these values. So the numerator will go to the denominator and the denominator will go to the numerator. That means that the hypotenuse over the perpendicular is equal to cosec theta. Then we have cos theta. So the opposite of cos theta or its reciprocal is sec theta. And sec theta is equal to the hypotenuse over the base. And then for tan theta, the opposite of tan theta is cot. So we can write cot theta is equal to the base over perpendicular. These are our 6 trigonometric functions. Now we have sine theta, its reciprocal is cosec theta. So if sine theta is multiplied by cosec theta, it will result in 1. But how? So let's prove that. So we can write sine theta cross cosec theta is equal to 1. So we need to prove how this is equal to 1. Now what is the value of sine theta? That is a over c. And what is the value of cosec theta? That is c over a. Now a and a get cancelled and c get cancelled, so that results in 1. So now instead of writing sine theta cross cosec theta is equal to 1, we can write sine theta dot cosec theta is equal to 1. But there is also another way to write this. We can also write that sine theta is equal to 1 over cosec theta. This also represents the same thing. Now, how did I write sine theta dot cosec theta is equal to 1 as sine theta is equal to 1 over cosec theta? We divided cosec theta on both sides. So when you divide that on left hand side, it get cancelled and sine theta remains, but on the right 1 over cosec remains. So this is why the trigonometric function is multiplied with the reciprocal and it is equal to 1. Now let's do the same for cos theta. So cos theta is equal to b over c, which means base over hypotenuse. So the opposite of cos theta is sec theta. Now sec theta will be equal to hypotenuse over base. So if cos theta is multiplied with sec theta, that will be equal to 1. But how? So let's place the values. We can write b over c cross the value of sec theta, which is c over b. Now the b and c get cancelled and that results in 1. So we can write cos theta dot sec theta is equal to 1, or we can also write cos theta is equal to 1 over sec theta. So here sec theta was divided on both sides. It got cancelled in the left hand side and on the right hand side it is 1 over sec theta. Now cos theta is equal to 1 over sec theta. This can also be written as sec theta is equal to 1 over cos theta. This is also exactly the same. We also need to check whether the reciprocal of tan theta is equal to 1. So tan theta is equal to a over b, that means perpendicular over base, and cot theta is the opposite of that, and that is base over perpendicular. So we can write tan theta cross cot theta is equal to 1. But the value of tan theta is A over B cross B over A, and A get cancelled along with B, so that gives us only 1. So we can write tan theta dot cot theta is equal to 1, or we can also write tan theta is equal to 1 over cot theta, as it got divided on both sides, and we can also write cot theta is equal to 1 over tan theta. Both of them are the same. So if we have a trigonometric function or a trigonometric ratio and we multiply it with its reciprocal, the answer will always be 1. Now, let's assume that we have a triangle which is ABC as given in the above figure. The base, let's denote that with B, and the perpendicular we are gonna denote that with A, and the hypotenuse we're gonna denote that with C. So by using the Pythagoras theorem, A square plus B square will be equal to C square. Now if you divide all of these values by C, that results in A square over C square added with B square over C square again, and that is equal to C square over C square, or simply just 1. Now A square over C square can be written as A over C whole square added with B over C whole square, and that is equal to 1. Now what is A over C equal to? That is equal to sine theta. So we can write sine theta whole square or sine square theta, and that will be added with the value of B over C. B over C is equal to cos theta. So we can write cos theta whole square or cos square theta, and that is equal to 1. So this is the derivation of the new formula. Sine square theta plus cos square theta is equal to 1.